Hello, Math for Life. This is Mrs. Bricky, and we're going to work on some right triangle stuff today. So here's a right triangle. Before we can get into the equations we're going to use, I just want to talk about labeling the sides and thinking about the names of the sides in a right triangle. So a right triangle, if you can identify where the right angle is, which is right here, that's a 90-degree angle. The two sides that create that 90-degree angle on each side of it, those are called the legs of the triangle. And the side that is across from the 90-degree angle is called the hypotenuse. So we'll be using those words a lot in this lesson. And then if you were thinking about the angles, if this is angle A and this is angle B, we know that angle A plus angle B has to be 90 degrees. Because the angles in a triangle add to 180. So if we have a 90-degree angle as one of the angles, we know that the other two angles have to add up to 90 to make that total of 180. We're not going to use the angles a lot today, but anyways, sometimes that comes up. All right, so we're going to review the Pythagorean theorem today. So the Pythagorean theorem is an equation that relates the sides of a right triangle. And the Pythagorean theorem tells us that if we have a leg of the triangle squared and we add it to the other leg of the triangle squared, it is equal to the hypotenuse squared. And so the two that are added together are always the legs, and the one that is by itself is always the hypotenuse. This one in the equation, it has to be the hypotenuse. And you've done this theorem before, used this theorem before, so hopefully you remember it at least a little bit. And so we've got these two triangles. It says find the lengths of the unknown sides of the triangle. So our first triangle, we know that this leg is length 6. Here's our right angle. We know this leg is length 8. And we're trying to calculate the length of the hypotenuse. So for the Pythagorean theorem, it's leg squared plus other leg squared is equal to hypotenuse squared. So in your calculator, you can add these two together. If you're doing it step by step, make sure you square those individually. So 6 squared is 36 and 8 squared is 64. You don't want to add them to be a 14 and square the 14. That would be a whole separate thing. That's different. So you can just type it in your calculator just like this if you want, or you can calculate them individually and then add them together. So 100 is equal to x squared, and then our last step will just be to take the square root of 100 to get our x value. So in this case, we get that the hypotenuse has a length of 10. In our second triangle, it has an 8 marked for one of the legs. When you see these kind of markings in a diagram, it means that those two segments have the same length. So this one is also 8. We're trying to find all of the sides, so we have found the other leg, and we still need to find the hypotenuse. So I'm going to label that with an X. So it'd be leg squared plus other leg squared is equal to hypotenuse squared. So if we, so you can either, type this straight into your calculator, or you can individually square those and then add them together. So we have 128 is equal to x squared. When we square root 128, if you're doing that in the little yellow school calculator, your answer is going to be left in radical form. If you're using like a different calculator, you might get a decimal answer. I think either of those is fine. So 8 root 2 would be the radical answer. In decimal form, that would be like 11.31. I think either of those is okay. So on this triangle, this is different than the ones that we have just done because we are given the length of the hypotenuse. And in this scenario, it's a lot more common for people to make mistakes. So this is a leg and this is a leg. When you're setting up your equation, the legs are squared and added together, and the hypotenuse is the one that is by itself. So that 12 squared has to be the one that's by itself. The other two legs are squared and added together. So in this case, to solve for x, we're going to have to do some subtraction. So if you want, you can do this two ways. I'll write it both ways, and you can see which way you want to do it. You can subtract the 9 squared if you want, like this. But a common error that people want to do is they want to turn this into a 3 squared. They want to subtract the 12 and the 9 and make it a 3, but that's not the case. You can't do that. So make sure that if you're doing this subtraction, that you actually do in your calculator type in a 12 squared minus a 9 squared, or you can square those out and subtract them. 12 squared is 144, 9 squared is 81. 144 minus 81 gives us 63. So we have x squared is equal to 63. And so when we take the square root of 63, in radical form, that's 3 root 7. Or if you have a decimal answer, that's 7.94. So just be careful. 12 squared minus 9 squared is not equal to 3 squared. You have to, the exponents here take precedence. You have to square those numbers out before you perform the subtraction. So just be really careful. That's the most common error that people make, is to try to subtract the numbers and then square, but that doesn't work. Okay, so let's try this one. Find the length of the side labeled A. So we've got a leg over here and another leg here that we are trying to calculate. And then the 13 is the hypotenuse. And remember, the hypotenuse is always the one that's across from the right angle. So in our equation, we would have maybe a squared, we might as well let the a come first, plus 5 squared is equal to 13 squared. So either be careful when you're subtracting, or you can square out those numbers if you want. I'm going to square them out this time. So we're going to subtract the 25. So we get a squared is equal to 144. And so when we square root, we get that a is equal to 12. This one's an integer. When you have a right triangle and all three sides are integer lengths, like 5, 12, and 13, that's called a Pythagorean triple. And there are lots of Pythagorean triples. Another really common one is 3, 4, 5. You may have heard of that one before, but there's lots of them. A lot of right triangles have a radical or a decimal as one of their side lengths, but there are some that are integers. All right, this one says find the length of this line segment. So this is related to Pythagorean theorem, because if we have a line segment on a plane like this, we can create a right triangle and use that right triangle to calculate the length of that line segment. So basically, we're treating that line segment like it's a hypotenuse of a right triangle. So we need to think about the lengths of the legs. And on our coordinate plane, we can just count the lengths of the legs. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So each of the legs has a length of 6. So leg squared plus other leg squared is equal to hypotenuse squared. I'm going to call that x. So we have 36 plus 36 is equal to x squared. That's a 72. And so when we take the square root to get our x value, Again, my calculator is going to give that to me in radical form. If you have a school one, it will do that. That's 6 root 2. Or if you get a decimal approximation, that's going to be 8.49, almost 8.5. Okay. All right, so here's a question. It says, find the area of the isosceles triangle with side lengths of 11 meters, 13 meters, and 13 meters. So this shape is a triangle, and we're trying to find the area. And hopefully you recall the area formula for a triangle. The area formula for a triangle is that the area is 1/2 the base times the height, or sometimes people write it as base times height divided by 2. That's the same. So we can see that our base is 11, but we need to calculate the height. So what we're going to do is the height of the triangle is always measured at a right angle. So this creates this little right triangle. And because this is an isosceles triangle, this is cut into 2 equal pieces. So if that base is 11, this part of the base is half of 11, and this part of the base is half of 11. It cuts it nice and evenly right down the middle. So we have a right triangle here where we have one leg that is length 5.5, and the hypotenuse is length 13. And h, the height of that triangle, is one of the legs of that hypotenuse. So if we set up a Pythagorean theorem equation, it's going to be leg squared plus other leg squared is equal to hypotenuse squared. So on this problem, because one of our side lengths is given to us in decimal form, we are going to end up with a decimal answer. 30.25 is equal to 169 is 13 squared. So we're going to subtract the 30.25. So we get h squared is equal to 138.75. So to get our final answer, we need to take the square root of 138.75. And I got for my height 11.78. I think 2 decimal places is probably fine. So now we know the height. So we knew the base was 11 from our diagram. We just calculated the height is 11.78. So our area equation is that it's 1/2 of, so multiplied by 11 multiplied by 11.78. So we get an area of 64.79 square meters. And that would be our answer. Okay, this problem says we have a square that is inscribed in a circle, and that circle is inscribed in a square, and we have this little diagram. These vertices of the square hit the midpoints of each of those sides. So each of this larger square its sides are being cut right in half. Consider the area of the region left by removing the interior small square from the interior of the big square. So our question is, so we've got, I'm going to color over the top of it. It's kind of complicated. So our question is, if we think about this space right here that I'm scribbling in black, if we think about this area, our question is the area of the blue region more or less than half of that area that I scribbled in? So we don't have any side lengths to work with here. So kind of we're thinking a little bit generally, but sometimes when you need to think generally, sometimes something that can help you is to think specifically. So let's just pretend for a minute, or let's just say for a minute, that this square's side length is 6. So that would make this one also 6. And that means that since these are exactly half, that each of these is 3. So what we have is 4 triangles. We have 4 triangles. And those triangles, because this is a 90-degree angle right here, because it's a square, those triangles each have a base of 3 and a height of 3. So the area of each of those 4 triangles, so the area of just one of them, is 1/2 of the base times the height. So that would be, if we calculate that, 4.5. And that was one triangle. So the area of 4 triangles would just be that number times by 4. So 4 times 4.5. So the area of the 4 triangles is 18. So this would be like the green, those green corners. They add up to an area of 18. All right, well, now we need to think about the blue region. The blue region is a little bit tricky to calculate. So it's got a circle with a square that's been cut out of the circle. So it's the blue circle minus the pink square. Well, the blue circle has a radius of 3 because the blue circle its radius is half of that square, that larger outer square, so the radius is 3. So for the blue circle, the area formula for a circle is pi times the radius squared. So this would be pi times 3 squared. And if you do that in your little calculator, it'll just leave it with the pi. So this is 9 pi. We need to subtract the area of this pink square from that. So if we subtract that area of the pink square, we'll get the blue, just those blue wedges. So in order to calculate the area of that square, we need to know how long the hypotenuse of one of these little green triangles is. So the hypotenuse, which is in pink, our equation for that little right triangle right there would be leg squared plus other leg squared is equal to hypotenuse squared, and I'm going to call that x. So 3 squared plus 3 squared is 9 plus 9, that's 18. So that means the hypotenuse is the square root of 18. Whoops. So that is, I think, let's go into decimals here. So this is about 4.24. That's the length right here. So I'm going to erase that and write that length there. 4.24. And so if we square that, because this is going to be the same, it's a square. The area of this square is length times width. That's 4.24 times 4.24, which is 18. So this pink area is 18. Okay, so to figure out these blue wedges, these blue like circle wedges right here, we need to do the area of the circle, which is 9 pi, and we need to subtract the pink square in the middle, which is 18. And so let's do that in our calculator. 9 pi subtract 18, and my calculator tells me that that is 10.27. So the question that we wanted to answer is that blue area more or less than half of what I have scribbled as the green triangles? And so since the blue area is 10.27 and the green triangles are, oh, my pen, sorry, my pen is like dying. Probably needs to be recharged. The green triangles are 18. So we can see that the blue area is a little bit more than half because half would be 9. Okay, so it's more than half. Oh my gosh, sorry, when my pen starts to die, the handwriting gets bad. Okay, that was the last example problem. So in class, you'll have a couple of example problems, some more straightforward, like the ones we started with, and then a couple of challenging problems like this last one. Work together, bounce ideas off each other, and see if you can get all of those solved. Thanks so much.